This is week 9 graded assignment 8. So in this week, we have to convert the Spark MLlib code, which is shown in this link. And we have to use the CrossValidator auto tuner and report on the best performing model parameters. So uh, this is our code, decision tree handwriting digit recognition. So we have to load the MNIST training and test data set. So I have used this code in the Google Colab, installed TensorFlow, and installed. I have manually downloaded the train and test data of MNIST dataset, and then we have to create a bucket. I have created a bucket of IBD week 9 and uploaded those MNIST test and train dataset, and then I've created cluster, and with the help of Jupyter Notebook in the data pro cluster, I have created week 9 IBD notebook. In this, I've installed the PySpark, and here is my all the dependencies which I have installed. So, and here in this code, I am dynamically creating a schema in PySpark to describe the data set. First, I have defined a label, uh, a field as an integer that cannot be null, and then using nested loops, I have generated 784 additional fields named in the format I cross j, where each field represent an integer value that can be null. These fields representing a 28 cross 28 grid, uh, I have appended to the fields list. And finally, I've used a struct type field to combine all these fields into the schema of the dataset. And in this block, I have loaded the train and test data, which is stored in the IBD week 9 bucket. And here in this code snippet, I'm preparing feature column for machine learning in PySpark using vector assembler. First, it extracts all the columns names except the first one from the training data set, and I'm using it as an input feature. And then the vector assembler combine these selected columns into a single vector stored in new column called features. This step is essential for algorithms in PySpark that require input data in a vector form. And then I am transforming the training and test data set. And in this, uh, I am setting up a decision tree classifier in PySpark with hyperparameter tuning and cross validation. So the model definition is created to predict labels based on the input feature with prediction stored in the prediction column. In the hyperparameter grid, uh, I have defined a grid of hyperparameters to tune, and next comes the cross validator. It is configured to evaluate the model using the specified parameter grid. It also uses a multi-class classification evaluator to assess model's performance based on the label and prediction columns. And I've specified five-fold cross-validation for robust evaluation. And then I am doing the best model evaluation with the help of this. And my best tree depth is 16 and best bin size is 4. So I'm scoring the test result, and the total test points which I have achieved is 9,999, and the wrongly classified count is uh, 11,144. I'm printing the wrong limit of two wrong images. So the true label of 5 is predicted as 4, which is shown over here, and the true label of 3 is predicted as 2. So this is all about IBD week 9 assignment. Thank you.